Alright, so picking up from the previous video, we're going to look at law of sine. So for this we're going to need a triangle, just label it A, B, and C. Draw a perpendicular line from B straight down. Perpendicular means that it makes 90 degrees. There you go. And then label that line H, so let it represent the height of the triangle. We're starting off with Sokoto again, or Three Old Angels Sitting on High Chatting About Heaven, however you remember it. And then across from each angle, label the corresponding side with a small letter. So let's take sine of the angle A. So label the triangle that's opposite, hypotenuse adjacent. So that's opposite over, which is H, over hypotenuse, which is C. H is subject by multiplying by C, so you get that. And then you're going to do the same thing for sine of C. So sine of the angle C, label the triangle O, H, and A. And then H and A in the equation, I'm going to need sine again. So sine of C is equal to the opposite, which is H, over the hypotenuse, which is A. Make H the subject, so multiply everything by A. So now you see we've got two H's, that's the exact same H's. So what can I do? I can put them equal to one another because the exact same H. And then there are two ways that you can see this law of sine. You can see it as sine A over A equals sine C over C by just moving the small letters. Or you can move the angles themselves and get C over sine C equals A over sine A. And I'm not going to go into the entire proof, but it actually turns out to be that it's true for all the angles. Sine A over A equals sine B over B equals sine C over C, or vice versa. In other words, you could do lengths over the angles. Alright, so now we're going to take a look at the law of cosine. Okay, so the law of cosine is similar. I'm just going to make my triangle on a coordinate plane just so that we can easily see x's and y's. So let's use that as angle theta with the sides A, B, and C. Alright, so I'm going to find that point there is A, and then 0 is the y coordinate. That point there is some length, which I don't know, and some height, which I don't know. So I'm going to find out what that is. Alright, to find out that height, I'm going to draw that perpendicular line triangle by itself so that I don't confuse you. Label the same size as before, and now I'm just finding out what those are. So using Sokoto once more, I'm going to find the distance on the x and the distance on the y. So let's say sine theta is what? Y, which is opposite, over hypotenuse, which is b. So sine theta is y over b. Make y the subject so I can know what the height is. So multiply both sides by b. So you're going to get y equals b sine theta. We're going to find out what x is. So I'm going to put in the y coordinate there. Y equals b sine theta. To find out what x is, we're going to use cosine, which is a over h, which is x over b. Solve for x. You're going to get x is b cosine theta. So that's the x value that goes over there. That point is the distance xy and then the height y. Alright, so now that we have this, I'm not sure if you know the distance formula, so I'm going to quickly derive the distance formula in case you don't know what the distance formula is. So, kind of like a little side note, so we're going to take a pause from the law of cosine real quick and do the distance formula. So the distance formula is actually derived from Pythagorean theorem. So Pythagorean theorem is you have a triangle like this, and I'm just going to put that same triangle on the coordinate plane so that we actually have x and y values. So what does Pythagorean theorem says? A squared plus b squared equals c squared. Alright, so c is actually now the distance I'm looking for. That distance there is a, which is the difference between x's. Just going to draw one more diagram without the triangle. So this is the distance I'm looking for, the distance between those 2 points, but I'm using the triangle to get it. So what does that say? If I label that x1, x2, and that y1 and y2, what the distance formula says is, what is the distance from here to here? So first you need to know what is that coordinate right there, which is that. What's that coordinate there, which is that. Pythagorean theorem says take this distance, square it, plus that distance squared is equal to d squared. So what is that distance there? Well, that distance there is going to be x2 minus x1. Square it, plus that distance there, which is going to be what? y2 minus y1. Square that, and that's going to give you c squared, which is now d squared. So simplifying that, you most likely see the distance formula like this, the square root of that. So that's how you get the distance formula. Now we're going to use the distance formula to find the distance between the 2 points of our original triangle that we were working with. The distance between these 2 points right here really can be done from this distance formula, and I'm going to leave it as c squared because I don't want to mess up it. So it's going to be x2 minus x1. So first thing I need to do is label it then. So x1, y1, x2, y2. So the difference between the x's, so x2 minus x1, so b cosine theta minus a squared, plus y2 minus y1, so y2 is b sine theta minus 0 squared. It's going to give me c squared. So c squared is equal to, now let's open this up, b squared cos squared minus 2ab cos theta plus a squared. And that the other one is just going to be b squared sine squared. Alright, let's, what can we do here? Oh, okay, we can bring, see there's that cosine squared, and there's also that sine squared. We know sine squared plus cosine squared is going to be 1, so we're going to bring it to the front and factor out b, leaving that. So we just brought it to the front and factored out b squared, sorry. So that's what we get, and we know that cos squared plus sine squared is equal to 1, so we'll simplify that to a 1, writing everything else out. And that's what c squared is the law of cosine. So we're just going to arrange it. I'm going to put the a squared in the front plus b squared minus 2ab cosine theta. Now what's really important to note is where A and B are the line segments that create the angle theta. In other words, A and B can't just be any lines, they are the actual line segments that create the angle. This is a listening check. Put a box around the word line. Put the box around the word line.
You gotta stay focused like way up. Bless up.
Okay, now that you know the law of cosine, it's very simple to prove the next bit that I need. Alright, so I just needed the law of cosine in order to prove this part. So again, you start off with a unit circle, so that's going to be 1. And we're just going to label our angles a little bit different than before. This one's going to be A, that little piece is going to be B. So that little section there is going to obviously be A minus B. Alright, so what can we label? Alright, so that's the distance D. The distance from those 2 points. So draw a right angle triangle, so it means draw a perpendicular line down there. And I'm going to put it here on the side again just so that it doesn't confuse you, and label it exactly the same. So it was angle B, and now we're finding that top right hand corner. That's what I need. So this is going to be my x value, my y value. Alright, so start off by labeling your triangle ONH, and that's also 1, so hypotenuse is also 1. Alright, using SOHCAHTOA again, I'm going to have cosine of the angle B is A over H, so that's x over 1. So x is equal to cosine B. So I'm going to put the x coordinate there on my point because that's that same triangle. Alright, do the same thing for y. So sine of the angle is opposite over adjacent. Opposite is y over hypotenuse, which is 1. So put that angle there, so sine B. Finding these 2 points, and now again I draw another perpendicular line so I can deal with this triangle. And just as before, I'm going to draw the triangle on the side just so that you don't get confused. Only this time the angle is what? A. See the whole angle there? It's A. Alright, the hypotenuse is 1. Label again O, A, and H. Okay, then we're going to find y and x. So start with cosine. So cosine of A is equal to A, which is x over 1, which is the hypotenuse. So that's the x coordinate. So that's what you write there. And then we're going to find the y coordinate, which is sine of theta is equal to y, which is opposite over 1. So that's the y coordinate, put it there. And now what we're going to do is find the distance between those 2 points D. Okay, we're going to find the distance between those 2 points D. So to find the distance, you need to label x1, y1, x2, y2. And we know from before the distance formula says you're just going to take the difference of those. So d squared is equal to x2 minus x1, which in this case is cosine A minus cosine B squared. This is a listening check. Color in d squared. Color in d squared. Plus the difference in the y's, sine A minus sine B squared. And then we're just going to open this up, so we're going to square it out. So we're going to get d squared is equal to cosine squared A minus 2 cosine A cosine B plus cos squared B. And on the other one, you're going to get plus sine squared A minus 2 sine A sine B plus sine squared B. Alright, now what can we combine? So we're looking for cos squared, because you see this cosine squared right there in the pink. And, oh, that's cosine B, that's a different color. I need to do that one in a different color. Alright. fixed it. So b's with b's, a's with a's, basically. Right, so there's a cosine squared b plus a sine squared b, that's going to be 1, and a cos squared a and a sine squared a, that's also going to be 1. So I'm going to have d squared equals that 1 plus the other 1 minus whatever is left, 2 cosine a cosine b minus 2 sine a sine b. Alright, then what can I do? I can factor out 2, negative 2 actually for both of these, leaving cosine a cosine b minus 2 sine a sine b. So we're going to keep that just like that for right now. I'm going to come back to it. Alright, so I'm going to equate it, I'm going to find b another way and equate it to that. So, using the law of cosine that we just did, I'm going to use that to find b. So, what does the law of cosine say? Law of cosine says, and by the way, you need to memorize this, c squared is equal to a squared plus b squared minus 2ab cosine theta. Whereas a and b is the line segments that make the vertex theta. So now put that into what we're talking about. C squared is d squared. A is this line there, which is 1, and B is that line there, which is also 1. And then the angle is A minus B. So we're looking at that little triangle there to find B. So d squared is equal to 1 plus 1 minus 2 times 1 times 1 cosine A minus B. Simplify that out a little bit, you're going to get 2 minus 2, and I'm going to factor it out, cosine A minus B. The reason I factor it out is you're going to see it in a second. So now I got two expressions for d squared, and they're the exact same d from the picture that we're talking about. So what can I do with those? I can put them equal to each other. So 1 and 2 are the same d squared and are therefore equal. This is a listening check. Color in number 1 circled. Color in number 1 circled. Alright, so write it out. So that's the first d squared is equal to the second d squared. Then we're going to simplify. So first thing I can do is subtract 2 from both sides, getting rid of the 2's. And then I can also divide by negative 2. Divide both sides by negative 2. That will get rid of those negative 2's outside. And then that's just going to leave me cosine of A minus B equals cosine A cosine B minus sine A sine B, which is a difference of angles. Now there's the difference of angles with sine, but it's another proof that requires half angles. So I'm just going to ask you to memorize it. So this is, I put all the trig identities we just found into our trig identity page. So this is what that page looks like. Honestly, the only way to remember these is to practice them. So we're going to do what we can in class, but I'm telling you, if you're not doing anything at home, then I don't know how you're going to remember all this. It's a lot, okay? So let's just get to practicing for real, for real.